So far, we've just looked at molecules where we have carbon and hydrogen atoms. Next, we're going to add a heteroatom, a single solitary oxygen, into the mix. This is going to allow us to make many more different sorts of molecules. We're first going to see molecules that have the formula C2H6. Here's one. It's ethanol. It has an alcohol functional group. The oxygen is bonded to a carbon and a hydrogen. What would happen if we replace the hydrogen with another carbon? We'd have this molecule. It has a new functional group called an ether. The two molecules have different functional groups, but they have the same formula. So they are constitutional isomers of each other. Let's move on from C2H6O to talk about C3H8O. Let's think about using an alcohol functional group again. Here, the OH, hydroxy, is attached to the end or terminal carbon. Could we position the hydroxy on a different carbon? Well, yes, we could. We could also put it on the middle carbon. Here's that molecule. The two molecules have the same functional group, but it's on different carbons. They have the same formula and are constitutional isomers of each other. What about this molecule? Careful now, think about it. Same sorts of atoms, same number of atoms. Hold on. Same bonds between the atoms. Whoa. This is the same molecule as the last molecule. The molecules are identical to each other. Lastly, in the 3-carbon series, let's look at changing the alcohol again into an ether. Here it is. We can see the oxygen is attached to 2 carbons. These 2 molecules have different functional groups, but they have the same formula and so are constitutional isomers of each other. Lastly, we'll take a look at C4H8O. As you can see, we can think up a number of different possibilities here. You'll notice each molecule has different functional groups, but they have the same type and number of atoms. They have the same formula. So despite having different functional groups, they are all constitutional isomers of each other because they share the same formula.